Alright, so we're going to talk about the domain and range of a function. Now we'll actually talk about the definition of a function in the next video. But domain and range are pretty easy to work with. Just to have a general idea of what a function is now, it would be, I suppose I'd describe it as either a rule or a graph. Alright, so f of x is just another way of saying y, so if we thought of this as y equals 3 times the absolute value of x plus 2 minus 5, that would be a function. It has a rule. We can look at its graph. Matter of fact, I've set this calculator up so we could scroll over and take down its table of values. Alright, so let's enter this. That is y is equal to 3 times the absolute value, which is in the math number menu of your TI-83 or 4. Absolute value, x plus 2, I press right to get out of the absolute value menu, and press 3, oh, not 3, minus 5. Okay, if we press graph, we can see what the function should look like. Alright, so it should look something like that, and second graph for a table. And if you notice, it looks kind of like a parabola, so it kind of has a symmetry going. So let's scroll till we find a symmetry. And if memory serves, the midpoint appeared to be in the middle, so it seems to be around here. So that's our table we can use. So -5, -4, -3, -2, -1, 0, 1. Goes 4, 1, -2, -5, -2, 1, 4. So those are our coordinates. I'm actually going to turn off the calculator now and scroll back to the main screen. Okay. Okay, so there's our table. We can now plot this and take a look at it. -5, 4 would be here. Okay, just plot all these points. There are more. This is all we need. Okay, there appears to be a pattern here. If we continue, it should go something like that. Continue over here as well. Okay. Alright, we'll draw some lines here. Okay. So that's one line going that way and one line going that way. Alright, so that's the absolute value function. And let's talk about what domain and range mean. Now, domain means the values of x that can be input into this function. So that's these values here. And it appears that we can plug any x value in here and get some value. If I pick this value over here, I'm going to get some value all the way up top. Whereas if I pick a value all over here, I'm going to get some value all the way up top. So the domain of this function would be written like this. X, and this symbol, which is kind of like half an absolute value bar, it means such that. So the domain of this function is x such that x can be found between, between -infinity and infinity. Okay? So that's the domain. It might also be written as this symbol, which means all real numbers for the real number system. That's every number on the number line. And now let's take a look at the range of this function. Okay, so the range of this function are all the y values it can take on. So if we were to scroll up and down this list here, all the y values it can take on. It seems to have a minimum point here, and it seems to go up forever. Okay, so because it has a minimum here, it can't go any lower than that, and it can go up, and it doesn't look like no matter where we go, we'll get there. So the range of this function would be, because this is f of x in this case, we'd write f of x, but if it were y, we'd write y. So f of x such that f of x is between in this case it can be equal to. You can't be equal to negative infinity or infinity. So it'd be between negative 5 and positive infinity. Okay? That'd be one way to write this. Another way to write it would be to say this. Alright. We could also say that f of x is strictly greater than or equal to negative 5. Alright, so that means all f of x values are greater than or equal to 5, meaning just this way and up. Okay, so let's write up another function. Alright, let me erase all of that. Okay. Here's one. This is, erase the graph as well. Okay, so here's the function. I'm just going to call it y in this case. Y is equal to 1 over x. Okay, so at 0, we are undefined. At negative 1, this is equal to negative 1. At 1, it's equal to 1. I'm kind of plotting these at random. So when this is 2, this is a half. When this is negative 2, it's negative a half. When it's a half, this function is actually equal to 2, and at negative a half, this function is actually equal to negative 2. I didn't put these in a particular order, but to get a good look at it, it looks something like this. Plug in 2, we get a half. Okay, so this is this side of the function, and this is the other side. Okay, it looks something like this. So, what is the domain of this function? What values can x take on? X such that it appears that there's a value for all values of x except 0. 0 is undefined in this function, so it doesn't have a y value, so it's not in the domain. So the domain of this function is x is not equal to 0. You could also write it as this. X is greater than 0, and, or, not and, or, x is greater than 0, not greater than or equal to, or x is less than 0. So that covers all values except for 0. So those would be acceptable values. The y values, or the domain, the range. If we look at this function, in this case it's y, so the range of this function is y such that, what y values can we take on? Goes all the way up to infinity, goes all the way down up to 0, but does not touch 0. Then it comes from this side and does not touch 0 and goes down to negative infinity. So similarly, y is not equal to 0, or we could write it as y is less than 0, or y is greater than 0. So just like in the other case, same exact thing. Alright, so let's come up with another function. Maybe one last one would cover this. Alright. G of x is equal to 1 over 1 plus x. Okay, so if we put 0 in the middle, 1x is 0, we have 1, 1x is 1, we get a half, 2, we get a third, 3, a fourth, and so on. At negative 1, we are undefined, because that would be 1 over 0. I'm just going to write UND. At negative 2, we get negative 1, and so on. So this is very similar to the last function. Slightly different. Matter of fact, it's the same function, but moved over exactly one space. So this function actually looks like this. It approaches negative 1, and then moves this way. And this one approaches -1 from this side and goes down this way. It's called a hyperbola. And we'll talk about that in the future. Alright, so the domain here is x such that x is not equal to -1, and y is actually still not equal to 0. So the range covers all real numbers except for 0. So g of x such that g of x is not equal to 0. Alright? So let's say we weren't actually given a function, we were just given the graph. We can still determine this. As a matter of fact, I'm going to make an interesting graph. I'm just going to draw. And it won't even be like a proper function. It'll start somewhere and it'll end somewhere. Okay. So here's my function. Its domain. The domain of this function is x is, how far does it go? It goes from, what is this, -7 all the way up to +7. So x such that x is between -7 and 7. Matter of fact, I'm going to make this an open circle, meaning not to include it. So it's so that point is not part of this function, but this one is. So because of that, this is -7 is less than or equal to x, and x is strictly less than 7. Not equal to 7. You can never actually reach 7. Alright, and the range of this function are the y values it can take on. So y, if we look at the y values, it goes all the way down to 4 in this case. Matter of fact, I want to change this a little bit. Makes a bit more sense. I have this stop over here. Okay, so this is our open circle. So y goes all the way down to -4 and all the way up to 3. So in this case we have y such that it's between -3. It does reach -3, and it goes up to 3. Oh wait, -4. Excuse me. It went down to -3. Down to -4. It does reach it, so it's less than or equal to, and it goes up to 3, and it does reach it, so it's greater than. So y is less than or equal to -3. So it's between those two values. All right. Let's take a look at another graph. This will be a weird one. An open circle there. This is called a step function. Also an open circle there. An open circle there. And I'll even do one more line over here. Closed circles on both sides. So the domain of that function, if we look at all the x values it could take on, it can go from -7. It does cover every value up to 3. So x such that x is between -7 and 3. Or, in this case, it also goes from 6 up to 9. So it kind of has a two-parter. So, or x is between 6 and 9, and it does reach both ends. Okay. Whereas the range in this case goes up to 6 at its maximum and goes down to -6 at its minimum. Okay, so this range is between 6 and -6. Alright, so it's easier to see it from the graph. You can kind of see what values make it undefined in the table. Let's take a look at one more. Alright, if we had the square root of x, then the domain is actually only positive. So x such that x is greater than or equal to 0, because there are no negative y values that can be plugged into this function.